Hello everyone, welcome back to my channel, and today we are going to start design and analysis of algorithms, a series from basic to the very advanced level. In today's video we are just going to see the basic part of any type of algorithm, like how do we start writing an algorithm, and what type of analysis does it have, and what type of representations does that it has. So we are going to see all those things in today's video, and let's start our video. Programming is basically divided into two parts, that is problem solving phase and the second one is implementation phase. When you come to the problem solving phase, that means suppose you are having a question and now you are framing the steps, like what do you have to do. First you need to start, then you need to create some condition for it to solve the problem, and then using that condition your question will be solved, and that's the end of the problem. So this is basically how you solve a problem. So this is the problem solving phase, which you do it on your pen and paper. But when you come to the implementation phase, it is nothing but writing the code in the computer. Okay, so this problem solving phase is known as the algorithm. Okay, so now if we look at some characteristics of algorithm, then the first one is finiteness. That means an algorithm must always terminate after a finite number of steps. See, if it is having infinite number of steps, then there would be no answer for it. So that's the reason finiteness is very important. Next is definiteness. That says that each step of an algorithm must be precisely defined. That means every step that you are doing, that has to be defined properly. That means when you start reading your code, you need to understand what you have written. Suppose you want to create int salary, then you create int salary. So there is a definiteness in the algorithm. Next is the input. An algorithm has 0 or more inputs. Okay, when you come to an output, it must have definitely one output, whether you give an input or not, but definitely an algorithm has an output. That's where your problem gets solved. So next is effectiveness. Effectiveness is nothing but all the operations to be performed in the algorithm must be sufficiently basic so that they can in principle be done exactly and in finite length of time. Any code that you are writing, it has to be in finite number of lines. It's not that you are writing a big code all the time. So it has to be effective, whatever code you are writing. So these are the 5 main characteristics of an algorithm. Now when we come to the difference between pseudocode and an algorithm, then we'll understand it using an example. First let us understand what's algorithm, and then next we'll come to the pseudocode. When we come to algorithm, now if we take an example to write if a person is failed or passed in an exam, then we take the help of average. So in case of algorithm, how you start is you write it in, it's basically a pure English format of writing a particular problem. So first you start, next you take all the inputs. Suppose I'm taking 3 inputs for now, that is M1, M2 and M3. Next is you take the average of it. That means the grade must be M1 plus M2 plus m3 upon 3. And next is if grade is less than 50. This is the condition we are taking. Then we print fail. Otherwise we print pass. So this is the end of the program. So this is how you have the clarity on the program. Next comes the pseudocode. Pseudocode is the actual code, but it is not run anywhere in the computer. Okay. So now if we look at the pseudocode, then we'll again have inputs, that is M1, M2, M3, and then we need to calculate the average. So calculate average equal to M1 plus M2 plus M3 upon 3. Third step is if average is less than 50. Okay. Then what do? We need to print fail. Else print pass. So this is how we write an pseudocode. So algorithm is basic English explanation of an program, and pseudocode is the code, but it is not used in the computers. Now if we come to the flowchart, so it says that sequence of instructions in a single program or subroutine. That means it shows the explanation of program step by step using the symbols. So let's see what each symbol represents. The oval shape, it is used for start and end, like where you start and where you end the program. And next, parallelogram, it is used for inputs and outputs. Next is rectangle. It is for processing. Processing is nothing but the arithmetic operations or data manipulations that you use. Like in the above one, we have calculated the average. That is sum divided by total number. So this is the processing. Next is diamond. Diamond is nothing but we use to make the decisions, like in if else. So we use them. The arrows are used for flow line, like which process comes after which. So for that purpose we use the arrows. Now let us see an example for pass or fail example using a flowchart. First, what do we need to do? We need to start it. So we start using the oval shape. Next we need to take the inputs. That means we need to use the parallelogram. So inputs, what we have taken above, M1, M2 and M3. Next comes the rectangle where we need to write our statement. Okay, to use the arithmetic operations. Grade, that is M1 plus M2 plus M3 upon 3. Next is we need to take the condition. That means we need to take a diamond shape. Now here we need to write that is grade less than 50. If it is less than 50, then it should print. If it is yes, then it will print pass. And since this is the output, it has to be in a parallelogram. And next, if it is a no, then it will print a fail. After finishing this, it will stop. So this is the end of the program. So this is how you write the flowchart. Okay. Now next, if we see the different types of flowcharts, then the first one is sequence control structure. That means there would be statement after statements. Like the first statement would get executed, then next this, next this. So there will be flow of statements. Now if you come to the selection control structure, selection, the term itself says that we need to select something. How can you select? We select based on conditions. So here we have condition. If it is yes, then it follows this. If it is a no, then it follows the else statement and then it ends up here. Next is the repetition control statement. It is used for loops. Suppose you are having a condition. If it is a yes, then it goes inside a loop. Then again, after the loop getting terminated, it again goes back and uses the same condition. So until and unless this condition is true, this loop will be running. If it is a no, then there would be no loop and it would directly end over here. So this is the repetition control structure. So in this class we have understood about different types of flowcharts, like how we represent an algorithm using a flowchart, and then we have also understood the difference between pseudocode and an algorithm. That is, algorithm is the basic English that you use to explain your problem, and next pseudocode is the code, but that is not actually run in a computer. We have also seen the characteristics of algorithm, and that's it. So that's it for this video. Hope you all have understood the basic concepts of algorithm. If you have understood, then don't forget to like, share, comment, and subscribe to my channel if you are new to my channel. And that's it for this video. See you in the next video. Until then, bye bye. Keep learning.